Hello students, welcome to another video on the chapter Atomic Structure for class 8. In the previous video, we have discussed about the history of atom and how different scientists discovered about the different parts or subatomic parts of the atom. Today we will be reading about Rutherford's planetary model as well as Bohr's atomic model. So let us begin. In Rutherford's atomic model, or also called the planetary model, there were certain points that Rutherford stated out. He told that atom is having a nucleus in the center, and most part of it is positively charged. He also told that the electrons are revolving around the nucleus, and he even compared his model to the solar system. It was compared to the mini solar system, where the nucleus is considered as the sun and the electrons are the planets that revolve around the orbit of the sun. But then it was not able to prove that how the electrons are not falling into the nucleus, because you know that the protons are positively charged and the electrons which revolve around them are negatively charged. So if positive and negative is there, it will try to attract each other. So obviously there should be some attraction and there should be some collision between the electrons and protons, which he was not able to justify. So then came the recent model, or the model given by Bohr. That's the Bohr's atomic model. Along with Rutherford also he worked, and also sometimes we call it as the Rutherford's Bohr model. Now this Niels Bohr is a Danish physicist. He also worked under the guidance of J.J. Thomson. So he agreed that the planetary model is somewhat correct, but he refined the model by stating that the electrons are actually moving in a specific path around the nucleus, and he called this path as the orbit. Other names are also given to orbit, like it's called shell, it's called the energy level. So electrons are moving from lower orbit to higher orbit only by losing or gaining energy. So it was also seen that electrons are able to move or change their orbit at times. This model addressed the flaws which was in the Rutherford's model, and even Niels Bohr, he won the Nobel Prize in Physics for his work in atom. If you see somewhat like this is the structure of a typical atom, where you can see the nucleus. There are two colors shown here showing that proton and neutron are there in the center, which is a positive charge, and around them is the round circles which you can see, which are called the orbit, and in them is the electrons revolving around in those given orbits. Now, slowly the discovery was made, and many physicists, scientists, chemists, they worked on it, and more discovery was done. It was then observed that nucleus of the atom, that is the center of the atom, is made up of proton and neutron. Now this neutron is nothing but an uncharged particle, you can say, with the same mass as that of the proton. The proton was first observed by Goldstein, and then it was named by Rutherford. And proton is a positively charged particle, and it is having the same weight as the weight of a hydrogen atom. Hydrogen atom is the lightest atom. It is around just 1.67 into 10 to the power minus 24 grams. So proton is almost the same weight. Also, proton, as I told you, it carries positive charge, and the charge in coulomb is 1.60 into 10 to the power minus 19. Neutron, which is another subatomic particle, was discovered by James Chadwick. So even Chadwick, he got the Nobel Prize in Physics for his discovery of neutron. And as we understood that atom is divided into three different types of particles here, as you saw, that is electrons, protons and neutrons, and these particles are known as fundamental particles or subatomic particles. Now when we talk about the structure of an atom, going into the detail, you know that mass of the atom is mostly in the nucleus, the center part, which is consisting of the proton and neutron. The nucleus is almost positive only, because neutron does not have any charge. It's only the charge of the proton in the nucleus. And the third kind of particle which you can see revolving around in this orbit, that is electron, they are the negatively charged parts of an atom. So you can tell that atom is electrically neutral. Why? Because the number of electron and the number of proton in an atom is seen to be equal. So there is a term called atomic number, and this atomic number is different for each element, and you know that there are 118 elements known to us till date. So this atomic number can be defined as the number of protons present in an atom. It is represented by the letter Z, and no two elements are having the same atomic number, so you can say that they are unique for each one. And the mass number is another number which is the sum of the number of proton and the neutron. So if you want to know the number of neutron, you can simply subtract the number of the mass number and the atomic number to get the number of neutrons found in the nucleus. The mass number is represented by the letter A. Here A denotes the mass number and Z denotes the atomic number. Talking about the characteristic of atoms, we can say that the number of protons in an atom is unique, and that is what distinguishes it from the other elements. And as we told, 118 elements having different 118 atomic numbers represented by the letter Z. Also, the number of electrons is equal to the number of protons, as I told you. So the atom as a whole is neutral. And the mass of the atom is concentrated in the nucleus, which is containing the protons and the neutrons, which are held together by a strong force which we call the nuclear force. The total number of protons and neutrons in an atom is called the mass number, which we are showing by the letter A. And the number of neutrons in an atom can be obtained by subtracting Z from A. The electrons, they revolve around the nucleus in fixed orbits, and they take part in the chemical and physical changes. So the electrons play a very major part. The properties of an element depends upon the number and orientation of the electrons in an atom. Means how many electrons are there, how many is taken, how many is given. As you proceed in the chapter, you will be knowing about those. Even the size of the nucleus is very small as compared to the size of the atom. Like I can say, if you have seen a cricket field, and if I keep the cricket ball in the center of that field, the size of the nucleus is that small. So here, if there is a question to you that this particular value is given, that the atomic number is 13, the atomic mass is 27, and Al represents aluminum. And what is the atomic number? Here, as I told you, atomic number is the number of proton. So proton is 13, and you know that in an atom, the number of proton is equal to the number of electrons. So that is also 13. So how do we calculate the number of neutrons? We need to subtract the mass number, that is 27, from, and the atomic number, that is subtract atomic number from mass number. So here we get 27 minus 13, that is equal to 14. So we can conclude that the number of protons in aluminum is 13, number of electrons is also 13, and number of neutrons is 14. That is mass number minus atomic number. So with this general concept of atom and the characteristics of atom, I am very sure you are ready and willing to see the next part, which is going to be very interesting, coming up in the next video about electronic configuration. If you have liked the video, don't forget to hit the like button and comment on the video. Thank you for watching.